All right, so in this video, I'm going to talk about some fundamental results about circles. All right, so we're going to go over a bunch of equations for it and then just fundamental results about this thing. So there is an equation for a circle. It's a very important equation. Now, there's a couple of things to know about a circle in order to specify everything about it. What I mean by that is, where is it centered at? I mean, is the center of this thing located in space out here? Is it located over here? The center of a circle is located right here. So let's call the center of this circle x sub 0. So this is just the x coordinate of the circle, and this is the y coordinate of the circle. So it's centered at that point. And we also have to know how big this circle is, the radius of it. I mean, is it huge? Is it small? So we have to know the radius of this thing right here. So let's denote this radius as r, radius r. Now, in order to write the equation of a circle, so I just mapped this point from the center with the radius r to this value along the edge. I'm going to call this point, which I'm trying to write an equation for, the x coordinate of, and then I'm going to try and write an equation for what y is here. So the equation of a circle is going to be based off of this relationship. Now, if we look at this point and this point, we can actually form a right triangle between those 2 points there. So here's a right triangle. Now, the distance in the y direction, so we're just going to use the Pythagorean theorem here to write an equation for this thing. The distance from here to here is, so we're going top minus bottom, so it's y minus y sub 0. The distance traveling this way is going to be x minus x sub 0, right minus left, x minus x sub 0. And it doesn't necessarily matter if this is positive or negative, because when we use the Pythagorean theorem, we end up squaring the value anyways. So it doesn't matter if it's positive or negative there. But it's typically done this way. So by the Pythagorean theorem, we know that this value squared plus this value squared must be equal to r squared. So we're going to go x minus x sub 0 squared plus y minus y sub 0 squared is equal to r squared. So that is the equation of a circle. So this is an important equation, and we can figure out what x and y are, and we can figure out what y is as a function of x by reorganizing this thing. All right, so this is the equation of a circle. Let's go over some examples of it. So let's say a circle has an equation x minus 4 squared plus y minus 16 squared is equal to 25. And it is asking us to figure out how to plot it. So the first thing is, again, the equation of a circle is x minus x sub 0 squared plus y minus y sub 0 squared. That's the center of the circle, is equal to r squared. So the center, what we're thinking of here is that the center of it must be the point 4, 16. You can kind of think of it as the opposite value, because x0 is going to be 4 here to get that to match. So this is going to be 4, and then so the opposite, so 16. You can also see that y sub 0 is 16. So the center of this thing would be at the point 4, 16. Now the question is, what is the radius of it? So the radius is also important. Notice that r squared equals 25. So r squared equals 25. Therefore, if we take the square root of both sides, the left-hand sides and the right-hand side, what happens is that r must be equal to 5. And we only are considering the positive value here because the radius is going to be positive. So this point right here, the radius of it is going to be 5. So the radius is going to be 5, and that specifies everything about our circle we need to know. All right, let's do another one. Let's say we had something that looked like this. Let's make it 60. Okay. All right. So what is the center and what is the radius of this circle? Let's say we're asked to determine those two things. Again, what happens here is you're going x minus x sub 0 squared plus y minus y sub 0 squared is equal to r squared. Now it's kind of hidden here, but I'm going to show you a little trick. See how this is positive here? It's always going to be opposite in the house. So it's going to be negative 15, negative 9. So the center of the circle is going to be negative 15, negative 9. Now, the way to see that, because it's kind of tricky here, why does that match with that? Well, you can rewrite x plus 15 as x minus a negative 15 here. So this whole quantity is x minus a negative 15 squared plus y minus a negative 9, because this is going to give me a positive, squared is equal to 16. Now you can see here that it's obvious that the center is negative 15, negative 9, because that's the x coordinate and that's the y coordinate for the center of the circle. And the radius of the circle, well, we know 16 is really 4 squared, so the radius must be 4. All right, let's do one more. Let's just say we were asked to determine the radius of a circle. Let's make it x minus 7. Actually, center and radius of this thing. Let's make it 8. Okay, let's do this. All right, so let's determine the center and the radius. Well, the center, again, is going to be, you're thinking the opposite. So instead of negative 7, it's going to be positive 7. Instead of plus 9, it's going to be negative 9. So it's 7, negative 9. And again, if you want to see that step, it's y minus a negative 9 here. So there's my negative 9. And it's x minus 7. So the 7 is just right there. So the center is at 7, negative 9. And let's figure out what the radius is. So this value right here is equal to r squared. So if I take the square root of both sides, we know that r is the square root of 8. In other words, it's equal to, well, what's 8? 8 is the square root of 4 times 2. We're trying to simplify it more. Square root of 4 times the square root of 2. We know we can do this with the square root. We can break it apart like that because we're multiplying here. Square root of 4 is just 2, and then times square root of 2. So this is what it would look like, completely simplified, the radius of it. So that is how we would write the equation of a circle and figure out what its radius and what its center is. All right, now I would like to talk about the arc length of a circle. When I refer to arc length, Well, what is arc length? Arc length is the distance around it. So if I was going to take a string and measure the distance around a circle, that would be its arc length. Now, the circumference of a circle is 2 pi r. So it's 2 pi r. The area of a circle is pi r squared, but the circumference is 2 pi r. Now, this term is going to be theta. So what we call theta is, so if we look at, so from here to here, we can think of theta as the measurement going around the circle. So theta here would really be 2 pi. So theta can be thought of as equal to 2 pi when you're thinking of going around an entire circle here. So theta is going around 2 pi, and then the radius is r. And this would give us our distance around the entire circle. So if I was going to take a string and measure that distance out, wrap it around the entire circle, it would be 2 pi times r. Now, this is interesting though, because if we consider theta to just be like 2 pi, well, we have this relationship with this measurement going around the entire circle and degrees. So what a lot of times we'll do is we'll think of degrees and this 2 pi, this theta value, as 2 pi is equal to 360 degrees. We'll think of it as going around 360 degrees. And what we refer to this value here as radians. So radians equal to 360 degrees. All right, so what this means is this value, so 2 pi radians is equal to 360 degrees. We can think of this as a unit conversion now. And a lot of times, so what we can do is we can divide both sides by 2. So we would get pi radians is equal to 180 degrees. So if I was traveling around the circle and I went around pi radians right here, this would be 180 degrees. Well, that's interesting because couldn't we figure out if this was 180 degrees and here was a circle with a radius, let's say this was 3 inches. The radius was 3 inches. We could just figure out the circumference, the arc length, not of the entire circle, but we could just figure out the circumference of the upper half of a circle here. So the arc length of this from here to here would be just the radius, so it would be 3 times whatever this is in radians. Well, we know 180 degrees is just, that's just pi radians. So it would be 3 times, so it would be r times theta, or theta times r, so it would be 3 times pi would be the measurement from here to here. So let's do one more example. So it's just r times theta. That's the equation for it as far as arc length goes. We're going to measure that distance with a straight line and go out. It would be the radius times whatever that is. All right, let's talk about one more. All right, so this will be the final example, arc length example. This is the best example. So let's say we have a circle and its radius is, let's make it 10 inches. So it's 10 inches. And we took its measurement, so this angle from here, so we have this circle, and this measure from here to here. Let's say this is 30 degrees. And we're asked to determine what is the arc length of just this right here. I'm going to make it red. So if we were asked to figure out what this distance is from here to here, and it's a curve, so we're asked to determine arc length. This is arc length. What does that equal? And again, the formula for arc length is just the radius times theta, and theta is measured in radians. So if we have 30 degrees here, so we have 30 degrees, and we're wanting to figure that out, what that is in radians, well, we know that 180 degrees is equal to pi radians. So the degrees cancel out. And then 30 divided by 180, well, we can just ignore the zeros kind of cancel out. Well, 3 divided by 18 is really, so you get pi over 6 radians. So theta would be equal to pi over 6 here. So the arc length, well, that's the radius is 10, so this would be 10 inches, so it would be 10. And then theta would be pi over 6, so you get 10 times pi over 6. And this is going, so this is in inches, so this is also going to be in inches. And then 10 over 6, well, that is equal to, all right, so the numerator you can divide by 2, so this would be 5, divide the denominator by 2, so this would be 3, so you get 5 over 3. So 10 over 6 is really 5 over 3, so you get 5 over 3 times pi many inches would be the arc length there. So we can see that if we're wanting to convert from degrees, what we have to do is we cancel out units, which we already talked about earlier on in the year. We have to put the degrees down here, how many radians it's equal to. We convert it to radians, at which point in time we can take that value and plug that value in for theta. We multiply it by the radius, and whatever unit the radius is going to be the unit for your arc length at the end of the day. All right.